A lot of people don't understand why I remain focused and concerned about the outcomes around the pandemic years upon years after starting speaking about it. And if you understand where I'm coming from and some of the basics as to my scientific extrapolation, you'll understand why I have this concern. And as I reflected on it, I came across a post that I did maybe 5.5 years ago on LinkedIn. So I've been on LinkedIn for a long time. I've been removed at some point because my questions were just too inconvenient. Back, but I'm hanging on by a thread, so to speak. But here is the post that I did 5.5 years ago. And it was essentially history repeats itself, diseases return in different forms. And this was me highlighting whether or not COVID 19 was a modern day rheumatic fever. Okay. And this is essentially what I had been talking about 5.5 years ago. Now, why was I talking about it then? It was because I recognized autoimmune responses as central to severe COVID 19. If you are not aware of this, this is fundamental to the science. And it is where there is a difference between most other viral infections, respiratory viral infections, and COVID 19. And it's this: if you take influenza damages your lungs by replicating in your lungs and causing inflammation and sometimes secondary bacterial infection. And the virus actually damages the cells. In COVID, very often, and you have to think carefully about this, when people have very mild or even asymptomatic COVID, they literally have no symptoms, but they may have had an infection. And what differentiates severe COVID from people having literally no symptoms is the immune response. I want you to think very carefully about this. This is very important science. The virus, the SARS-CoV-2 virus, unless someone has very poor immunity, if they're chemotherapy, very immunosuppressed, it doesn't do the damage in terms of the virus replicating in cells. Now, it does cause some damage. And when you look at scans of the chest after a COVID infection, even in people who have mild symptoms, there is inflammation. So it definitely causes inflammation, but not usually enough to kill them. What causes somebody to die is the immune response to the infection, and that leads to a cytokine storm. It's really important. Let's follow it again. It is not the virus per se, unless you have severe lung disease or other conditions. But in a normal lung, somebody could still die of severe COVID because of the immune response to the virus, right? Really important differentiation. So, what I was likening this to is rheumatic fever. Okay. And you have to follow along the science with me to understand what we're talking about. So, rheumatic fever is a disease of children. And what happens is that children, when they get infected with a specific bacteria, group A streptococcus, in a small percentage, it can cause their immune system to overreact and lead to rheumatic fever. It's probably the most significant cause of heart disease in children across the world still. Not so much an issue in developed countries, but certainly in other parts of the world, this is still a very real problem. We've had this issue for a long time, maybe close to a century. And you know what's interesting? There is still no vaccine for rheumatic fever. Now, you have to think about this very carefully. And you have to wonder, there are a number of reasons why, but I thought that it's important for you to grasp this point here. So this was in February 2023, and they were looking at the vaccine landscape because they're still trying to make a vaccine for this significant condition. And so they've had recent efforts to reinvigorate the Group A streptococcus vaccine development field. But there are a number of barriers that persist. And they are currently 8 candidates on a product development track, including 4 of them targeting the M protein. Now, this M protein is the problem, and 4 designed around non-M protein antigens. So, in the context of rheumatic fever, I liken the M protein to the spike protein. Okay, and this is where we're getting the parallels, because the problem with the M protein is that it is very similar to a normal protein in children, or yes, a normal protein in the body, but specifically relevant, especially in children. And so, if the immune system targets the M protein on the bacteria through molecular mimicry, it can then also at the same time target the same protein in different parts of the body. And this is why they get heart problems, skin lesions, brain disease. Okay? That's the parallel, the perfect parallel, in my view, to COVID-19. COVID is more of an immune and vascular disease. It infects the respiratory tract, but it damages the blood vessels and it overstimulates the immune system. So, when you think about that, and this is the targeting for that, what they were looking at with rheumatic fever, you have the M protein here, and the problem they've got is that if they target the M protein and trigger the immune system to target it, can it overreact? And so they're looking at some of the other proteins on the bacteria to try and come up with a vaccine for it. Now, remember, this disease is the most significant cause of cardiovascular disease in children. And we have still not come up with a vaccine for it. And as I said, the reason is purely about logistics. What put them off in 1979 was an important study. And in that study, what they found was that after they gave them the vaccine, in 3 of the cases, and this was a small group, 21 healthy siblings of patients with rheumatic fever, because there is some genetic risk, were vaccinated with type 3 M protein. What they found is during and following this vaccination, children experienced a rise in the titers, what you want. However, 2 of them were followed by rheumatic fever, and then a further one by probable rheumatic fever. So, what they recognized is that most importantly, this experience indicates a need for caution in the use of streptococcal vaccines in human subjects. The reality is that we had the same issue when we were looking for vaccines for SARS-CoV. That's the first virus in 2003, up to 2012. When they were trying to develop vaccines for SARS-CoV, they found that every single type of vaccine triggered an immune pathology in terms of a T helper cell immune overreaction. And so this was always the worry, or should have been the worry, whenever you are looking at trying to bring an immune stimulant into a system where the immune system, if it overreacts, will cause disease. So all the way back 5 years ago, as I was trying to raise awareness of this, I then came up with a small 2.5-minute video, which I think is still relevant. And it's tying the response of the M protein or mannose binding lectin to what happens with ACE2 in severe COVID. Follow this and tell me if this makes sense to you. And so that's the reason why I put this together, because 5.5 years ago, I was pointing out that the main pathology in severe COVID was the immune system. If the immune system is overreacting in severe COVID, how do you train it to react perfectly in the context of a vaccine? And that's why at the time I was saying, please, guys, make sure you only target the high risk, because it's the high risk who are at greatest risk of severe disease. Therefore, you're most likely to get the benefits there. And if there are issues, therefore, you are still balancing off severe disease. What then happened, and I will call out anyone on this, I am happy to challenge anyone on the science, is that they started to go into the low risk cohorts because they mistakenly thought that they could stop transmission. A lot of people will deny that was why they did it, but that was the only logical reason. They mistook the fact that they couldn't block transmission. Therefore, when you are giving a vaccine to somebody who has low risk of severe disease, you cannot afford there to be any complications. And this was the reason why at that time I was making the point, please, whatever you do, do not take unnecessary gambles in low risk cohorts. And that time that included children. And I will still say there is too much that is unknown about the pathophysiology around severe COVID-19 and the fact that we are still not doing autopsies on people who have been vaccinated. They're just not there. There are few, a scattering. The first one was done in 2023 on an 83-year-old man, and I called it out at that time. I am still searching and waiting, because part of the question that should have been answered is whether or not what happened in animal studies with SARS-CoV would occur as well with T helper 2 immunopathology in the lungs or elsewhere. That's what I'm looking for and waiting for. It worries me that we still don't have autopsies. Either they can't be bothered, which would be negligent, or they already know and don't want to publish it. Whichever way we take it, it's terrible. There is too much that we still need to understand. And the point that I'm making is that, similar to what we learned with rheumatic fever, is that if you try and vaccinate the immune system against this bacteria, it's very difficult to prevent it from potentially causing more severe disease down the line on exposure to the bacteria again. Remember, when they looked at the outcome in this case, they recognized that on exposure, on re-exposure, in these cases, that's when they ended up with pathology. And this is the same concern that we could have today. There's still a lot of work to be done, but I still maintain that 5 years ago, when I looked at rheumatic fever as the best parallel to severe COVID, rheumatic fever is an autoimmune response to a bacterial infection, and severe COVID, in my view, was an autoimmune response to a viral infection. The two had very similar parallels. And I still maintain 5.5 years ago, that was probably one of my most valuable scientific insights, for which many people still don't quite understand. We still have a lot of work to do. But remember, if you want to support this research, remember to like, share, comment, and ensure that you subscribe. Have a great evening.
A hero, an immune adventure. Humming Heroes, your lyrical guide to the body's defenders. Now on Amazon. Check the links below.